Very good morning to one and all. Hope all of you are safe and children please take care of your health. I think from the news we are getting the duplicate area. The coronavirus is spreading badly. So please take care of yourself. Don't come out from home unnecessarily and please be safe and concentrate on your work how much ever it is possible. Okay, let us begin today's topic. I am going to explain how we are going to predict the voids. So far in the previous classes we have done what is solid, what are all the different types of solid, and we have done the calculation for packing efficiency, and then we have come across with what? We have come across with calculating the density, that is how we can calculate the density of the crystal and magnetic nature, and we have done the concept based on conductor, semiconductor and insulator and application. The last one more piece what we have left is how we are going to predict the formula of a compound. In solid state, we have two types of numerical. One is a regular mathematical numerical, that is by using the formula density rho is equal to Zn by A cube into Na. Now, one more type we are going to see is, it is not the calculation type, but you are going to predict. So, it is a kind of word problem that you are going to learn today, which is interesting, and you have to calculate it based on the data given in the question. So now in this slide, we are going in this session, we are going to see the two types of void. Already I have told you what are void. Voids are nothing but the small gap that are formed when the atoms are in contact with each other. The two types of voids are, one is called tetrahedral void and another one is called octahedral void. And we are going to see what is the relationship between tetrahedral void and octahedral void. And through the picture you are going to learn how to locate the tetrahedral and octahedral void in the forthcoming slide. And I am going to teach you the word problems also. Now let me explain what is the difference between tetrahedral and octahedral voids. What do you mean by tetrahedral voids? Point number one, it is surrounded by four spheres in the crystal lattice. If you want, you can represent it diagrammatically also. From this diagram, you can be able to see the dotted line that is represented is called what? It is called void. And over the gap of the first layer, we have allocated the second layer. So what is actually tetrahedral void? It is surrounded by four spheres, and then you can write one more point also. The second layer is placed over the void of the first layer, and then the coordination number for tetrahedral void is 4. Children, please make a note here itself. Coordination number for tetrahedral void is 4. Now see what is octahedral void. Octa means don't ever think that it is 8. It is only for IUPAC nomenclature. You will write octa, nana and all. But here in this case of octahedral void, it is formed by touching 6 spheres. Once upon a time, it is a board question, distinguish tetrahedral void and octahedral void. So tetrahedral void means formed by touching 4 spheres. Octahedral void means formed by touching 6 spheres. So what do you mean by coordination number? The number of nearest neighbor is called coordination number. So for tetrahedral void, the coordination number is 4, and for octahedral void, coordination number is 6. How, ma'am, the octahedral voids are formed means, if the third layer is placed over the void of the second layer. So if the second layer is placed over the void of the first layer, tetrahedral. When you keep the second layer, another new void will be formed. So the third layer, when you keep it over the void of the second layer, octahedral voids are formed. Children, now look at this diagram. I am going to teach you how to locate tetrahedral voids in a unit cell. Look at each small cube, you know very well, the contributing atom is 4. So, take a small cube in the crystal. Imagine that you are joining two opposite atoms. Either you look the individual diagram or you can look the three-dimensional crystal lattice. Any two opposite atom if you join, you will get what? you will get tetrahedral void. So, or the tetrahedral geometry. What information you are getting from this? Each small cube in the crystal is capable of generating two tetrahedral void. Now look at the first three-dimensional diagram, the front cube as well as the back. When you join these two tetrahedral void, you will generate one octahedral void, or you can say tetrahedral voids will be twice the number. Octahedral void is equal to 1 in number. So when two tetrahedral voids on joining, you will get one octahedral void. Children, once again I repeat. So please take a smallest portion of the crystal lattice, that is one unit cell, and you know very well the unit cell, the contributing atom, you join in the opposite side. Even though it has 8 atoms in the corner, you are going to consider two opposite atom, and if you join, you will get the shape of tetrahedron. Look at the separate unit crystal diagram. Now look at the three-dimensional diagram, the front simple cube and back. When you join these two simple cube, you will get octahedral voids. So tetrahedral voids, octahedral, when two tetrahedral voids combine only, you will get one octahedral void. Now we are going to start with important relationship between small r and capital R. What is small r? It is the radius of the octahedral void, and r is nothing but the radius of the sphere. Children, now look at the diagram. It is not the three-dimensional. You are imagining that it is a one-dimensional way. So don't think that octahedral means it should have 6 spheres. Look at that. The outermost, the big spheres indicate the radius of the sphere, and the inner, the smaller one, is indicating what? It is for octahedral void. So the outer sphere, the radius are represented with capital R, and then the octahedral void radius are represented with small r. Now we are going to use the Pythagoras theorem, and we are going to solve this derivation. Now after seeing the elaborate diagram, come here for mathematical expression. Imagine the BC square you are going to calculate from the diagram. BC square is equal to AB square plus AC square. Children, I am doing the explanation based on the smaller diagram, not based on the individual bigger diagram. So don't see that. BC square is equal to AB square plus AC square. What is BC actually? When you see BC, it is nothing but the edge length, which you can write it as R plus R, that is capital R, 2R. 2R the whole square is equal to, look at the dotted line in the inner circle, the capital R is for the sphere and the inner small r is for the octahedral void. So capital R plus small r will be common for both. You can write R plus R the whole square. So AB square also R plus R the whole square, and BC square also, AC square also R plus R the whole square. 2R square is equal to 2 into R plus R the whole square. On solving, on taking square root, root 2R the whole square is equal to R plus R the whole square, or root 2R. Remove the square both side. Root 2R is equal to R plus R. Take the small r this side. R is equal to root 2R minus R. Since R is common, you can take the R outside. Root 2 minus 1. What is the mathematical value for root 2? Root 2 is nothing but 1.414. So you can write small r is equal to capital R into 1.414 minus 1, which is nothing but 0.414 capital R. It is a frequently asked 2-mark question, and your backside question also derive the relationship between octahedral void and the radius of the simple cube. So what is the answer you are going to write? Radius of the octahedral void, that is small r, is equal to 0.414 times greater than the what one? 0.41 times capital R. This is the answer you are going to give. These are all the useful messages that you are going to learn from this tabular column. So what is the type of unit cell and what is the relationship between A and R? If it is simple cube, already I have told you A is equal to 2R. If it is body center, you can write R is equal to root 3 by 4A or A is equal to 4R by root 3. If it is FCC, A is equal to 2 root 2R or R is equal to A by 2 root 2. Children, look at this diagram. Most of the competitive exam, they will give example and they will ask the coordination number. Even though it is the additional information, I want to give this instruction to you. Just have, we don't have the calculation of radius ratio in the syllabus, but you can have the range of, for this radius ratio, what will be the coordination number and what type of void it will be generated and what is the example. Children, the second tabular column is only for competitive exam purpose. Now, generally, they will give the coordination number. After giving the coordination number, they will ask you to predict what type of void, or they will give the example, sodium chloride, magnesium oxide, cesium chloride, like that, and they will ask you what type of void is found in the crystal and what is their coordination number. Now, by using the void relation, we are going to predict the formula. Children, the important note that you have to remember forever is, let the number of atom in the sphere be represented as n. So, the number of octahedral void is equal to the number of atom, that is n. Tetrahedral voids will always be twice the number of octahedral void. Or you can write octahedral void is equal to n number of atom. Tetrahedral voids is equal to 2n number of atom. Look at the question how they will ask in word problem. It is a given simple cube system which consists of atom A occupying all the corner and B atom occupy the center of the crystal. Predict the formula. What information you are getting from this? They are giving, look at the diagram given here, children. It is a body centered diagram. Don't see the three-dimensional diagram, see the normal diagram. You can able to see 8 atoms in the corner and 1 atom in the center. So imagine the atoms A are in the corner. Instead of the dot in the corner, you imagine A. And in the center, it is represented as B. Now, they are asking what could be the formula of the crystal. We know that the contribution of atom in the simple cube. Let us take the corner A. How many atoms are in the corner? 8. So, 8 into 1 by 8. 8 and 8 will get cancelled. So, which is equal to 1? That is for A. A is equal to 1. What is the number of atom in B? B is nothing but body centered, only one atom. B is equal to 1. So, A is equal to 1, B is equal to 1. Therefore, the formula of the crystal is AB. Hope it is clear. Look at this question. In a crystal, B form HCP lattice and the element A occupy 2/3 of the tetrahedral void. What is the formula of the compound formed by the elements A and B? What information you are getting from this? A particular compound is having only two elements A and B. A is occupying 2/3 of tetrahedral void and B form HCP lattice. They have not given any detail for B. What is the formula that you are going to predict? Now, what detail I have given you for tetrahedral void? Always tetrahedral void will be twice the number of atom. So, what answer you can write? For that, you can write A is equal to 2 by 3 into 2. Why? 2/3 of tetrahedral void. So, 2 by 3 into 2 times. So, 2 by 3 into 2 is nothing but 4 by 3. So, you have calculated A's contribution is 4 by 3. Then what about B? They have given simply it is HCP lattice. You don't know anything about B. So, you can assume let it be X. Either you can use the term X or you can use the term 1. So, how you are going to predict? A contribution is 4 by 3 is to B contribution is X or 1. Or you can write 4 by 3 is to 1. How you will calculate the ratio? 4 by 3 is to 1, 4 is to 3. So A4, B3. Children, the 4 and 3 you have to write it as a subscript, not in the superscript. A4, B3 is the formula. So based on this only, you will be doing word problem. I will give some more problems in the next slide so that it will give you what better idea. Children, now look at the sample problem 3. In a cubic crystal, A atoms occupying corner and B atoms occupying center of each of the face. That is, in the center of every face you have B atom and C atom in the center of the cube. Predict the formula. Now you are going to do the sum in what way? A is in the corner. So how you are going to write? A is equal to 8 into 1 by 8. 8 and 8 will get cancelled. So A is equal to 1. B is occupying the center of every face. 6 into 1 by 2, so it is 3. C is in the body center, that is C is equal to 1. And what could be the formula? AB3, C is the formula. Okay. I will give some more sum for the practice. Today itself you are going to do and submit it in the Google Classroom.